Guys, sa nakaraang pinag-aralan natin, nag-research tayo about sa exogenic process. Ngayon naman, alamin natin kung ano ang endogenic process. Sa pag-aaralan natin dito, maiintindihan natin ang konsepto ng volcanism, earthquake, at deformation, pati na rin ang metamorphism. Sa pag-aaralan din natin dito, masasagot natin ang ilang katanungan kagaya na lamang ng kung bakit mainit ang kaloob-looban ng mundo at kung paano nabubuo ang magma, pati na rin kung ano ang nangyayari kapag nabuo ang magma sa loob ng mundo at sa labas nito.
Endogenic processes. It is the Earth's interior processes. It is driven by the energy and forces within the Earth. The sources of heat of endogenic processes may be the leftover heat from gravitational energy or disintegration of natural radioactive elements, or also called radioactive decay. Under endogenic processes, there are magma and volcanism, earthquakes, deformation, and metamorphism. Magma. Magma is the molten rocks that are found beneath the Earth's surface. It is less dense than the surrounding rock, but capable of rising the surface. When magma emerges at the surface, it is called lava. The abundant elements of magma is silica, aluminum, iron, calcium, magnesium, sodium, potassium, hydrogen, and oxygen. The melting temperature of rocks could range between 800 degrees Celsius to 1,400 degrees Celsius. Magma with high silica are more viscous than low silica magmas. Crystallization of magma. Crystallization occurs when magma pools and mineral grains starts to form. Some magma moves all the way to the surface, but some solidifies underground. Solidification of magma forms igneous rocks. Common minerals of igneous rocks are quartz, orthoclase, plagioclase, muscovite, biotite, amphibole, pyroxene, and olivine. Orthoclase and plagioclase are called feldspar, while biotite and muscovite are called mica. And when magma crystallizes, there is a sequence of the type of minerals formed. If a mafic magma crystallizes, the first mineral formed is olivine, followed by pyroxene, amphibole, biotite, muscovite, orthoclase, and quartz. A group of plagioclase follows a parallel sequence where calcium-rich plagioclase crystallizes first and sodium-rich plagioclase forms last. This sequence of minerals crystallization in igneous rocks is called the Bowen's reaction series. The resulting igneous rocks are classified based on composition and grain sizes. The composition of rocks is usually described in terms of the proportion of silica, magnesium oxide, and iron oxide. Ultramafic. It is a rock that are rich in magnesium oxide and iron oxide with a very little amount of silica. Felsic. It is a rock that is rich in silica, and when the proportion of magnesium oxide and iron oxide approximately similar to silica, then intermediate rock is formed. Next is the grain sizes of igneous rocks. The grain sizes is dependent on the rate of cooling of magma. Igneous rocks are formed underground, tend to experience very slow rate of cooling. They develop coarse-grained materials. Phaneretic. It is an individual crystals of each minerals that are visible to the naked eye. Then when rocks solidifies near the surface that experience fast rate of cooling and forming fine-grained materials, aphanitic are formed. Its crystals are visible only using a hand lens or a microscope. And the last one is phorphritic. It is a mixture of fine-grained materials and coarse-grained materials. Most magma never reaches the surface. However, they solidify underground and form bodies called igneous intrusions. It forms wall-like sheets called dike, or forms tabular layer called sill. It can also form a blob-like configuration called pluton and form amalgamation of many plutons that are called as batholith.
After we've learned some of the information about magma, let's move on now to the volcano. Volcanoes are visible manifestation of the process of rock formation. It is a vent that serves as the conduit of lava or the molten rock that reaches the Earth's surface. Eruption. This is the event when the lava spewed out of the volcano. There are two types of eruption. The first one is the effusive eruption. This eruption is dominated by the flow of lava and formation of fountains and lakes. Next is the explosive eruption. This type of eruption ejects ash and larger fragments of pyroclastic materials, forming ash clouds that eventually collapse and covers the slope of the volcano. The composition of the lava controls the type of eruption. The amount of silica in the lava controls its viscosity. In effusive eruption, the lava are able to flow more rapidly because the amount of silica content is low. That's why it is less viscous. Explosive eruption is associated with lavas having high silica content and more viscous. The dissolved gases in the magma develop very high pressure as it rises toward the surface. There are three different kinds of volcanoes according to its shape. We have the shield volcanoes, stratovolcanoes or composite volcanoes, and the last one is cinder cone volcanoes.
Earthquake. An earthquake is the shaking of Earth's surface resulting from the sudden release of energy in the Earth's lithosphere that creates seismic waves. Earthquakes are usually caused when rocks underground suddenly breaks along a fault. This sudden release of energy causes the seismic waves that make the ground shake. The primary effects of earthquakes are ground shaking, ground rupture, landslides, tsunamis, and liquefactions. Fires are probably the single most important secondary effect of earthquake. These are important factors of earthquakes. First, a fault. A fault is a crack in the Earth's crust. Typically, faults are associated with or form the boundaries between Earth's tectonic plates. In an active fault, the pieces of Earth's crust along the fault move over time. Next is the epicenter. The epicenter is the point on the Earth's surface directly above a focus, the point where an earthquake or an underground explosion originates. And finally, the elastic rebound theory. It is an explanation for how energy is released during an earthquake. As the Earth's crust deforms, the rocks which span to opposing sides of a fault are subjected to shear stress. Slowly, they deform until their internal rigidity is exceeded. Seismic waves are waves of energy that travel through the Earth's layers and are a result of earthquakes, volcanic eruptions, magma movements, large landslides, and large man-made explosions that give out low-frequent acoustic energy. A body wave is a seismic wave that moves through the interior of the Earth, as opposed to surface waves that travel near the Earth's surface. P and S waves are body waves. Each type of wave shakes the ground in different ways. P wave is one of the two main types of elastic body waves, called seismic waves in seismology. P waves travel faster than other seismic waves, and hence are the first signal from an earthquake to arrive at any affected location or a seismograph. P waves may be transmitted through gases, liquids, or solids. S waves, secondary waves, or shear waves are a type of elastic wave and are one of the two main types of elastic body waves. so named because they move through the body of an object, unlike surface waves. Surface wave is a 90-degree wave that propagates along the interface between different media. A common example is gravity waves along the surface of liquids, such as ocean waves. Gravity waves can also occur within liquids, at the interface between two liquids and different densities. Rayleigh waves are a type of surface acoustic wave that travel along the surface of solids. They can be produced in materials in many ways, such as by a localized impact of a piezoelectric transduction, and are frequently used in a non-destructive testing for detecting defects. Love waves are horizontally polarized surface waves. The love wave is a result of the interference of many shear waves guided by an electric layer, which is welded to an elastic half space on one side while bordering a vacuum on the other side. A seismograph, or a seismometer, is an instrument used to detect an earth and record an earthquake. Generally, it consists of a mast attached to a fixed base. During an earthquake, the base moves and the mast does not exist. A seismograph is a graph output by the seismograph. It is a record of ground motion at the measuring station as a function of time. Seismographs typically record motions in three Cartesian axes, with z-axis perpendicular to the Earth's surface and the x and y-axis parallel to the surface. Magnitude is a number that characterizes the relative size of an earthquake. Magnitude is based on a measurement of the maximum motion recorded by a seismograph. In simple terms, it is the number that indicates the size of an energy released in an earthquake. Meanwhile, intensity measures the amount of damage released at the source of an earthquake, usually indicated as Roman numerals. The Mercalli intensity, or more precisely, the modified Mercalli intensity scale, is a scale to measure the intensity of earthquakes. Additionally, it does not take into account the energy of an earthquake directly.
Deformation. It is a process in which rocks change in shape, size, location, tilt or break due to squeezing, stretching, or shearing. It is the dominant process in the formation of the mountain belts. Stress. In physics, it is a force applied per unit area. If the forces act uniformly from all directions, it forms a uniform stress, also referred to as pressure. The weight of overlying rocks exerts pressure, referred to as confining stress. If the force is not equal from all directions, the stress formed is called differential stress. There are three kinds of differential stress, namely tension, compression, and shear. Tensional stress. It occurs when the dominant force is directed away from each other, just like this. Compressional stress is formed when the dominant force is directed toward each other, just like this. Shear stress is formed when two dominant forces are directed to each other but not along the same axis, just like this. The resulting change in the rocks due to the different types of stress is called strain. It is the change in size, shape, or volume of the rock subjected to stress. It might be by stretching, which makes the object longer, or by shortening or contraction, which makes the object shorter. There are different kinds of strain: shear strain and elastic strain. Shear strain. It occurs when the change in shape involves movements in one part of an object relative to its other parts, such that there is change in angles features. Rocks can also temporarily change shape when subjected to stress, but can change back to its original form when stress is removed. This is called elastic strain.
Metamorphism. It is a process that occurs when a rock changes its form into a new one without undergoing melting or disintegration. The transformation involves several processes. First, recrystallization. It refers to the changes in shape and size of minerals without changing its identity. Next, phase changes. It is the transformation of grain of one mineral into a grain of another mineral. Next, neocrystallization. It is the growth of new minerals produced when chemical reactions digest existing minerals. Next, pressure solution. It refers to the dissolution of mineral grains when rocks are squeezed dominantly in one direction. Lastly, plastic deformation. It occurs when some minerals elongated without changing composition or crystal structures. Causes of metamorphism. Metamorphism occurs when temperature gets higher, or roughly between 200 degrees Celsius and 850 degrees Celsius, that cause the atoms to vibrate rapidly, causing chemical bonds to stretch and bend. Metamorphism also occurs when the minerals are subjected to extreme pressure that causes the crystal structure to become smaller and denser. Metamorphism occurs when there are chemical changes. There are several types of metamorphism. Contact temperature. When a magma causes the metamorphism because of the presence of high temperature and hydrothermal fluid. Next is boreal metamorphism. It is when sediments pile up and become thicker and the pressure increase due to the weight and geothermal gradient causes metamorphism. Next, dynamic or catalytic metamorphism. It is when recrystallization of minerals in the fault zone causes metamorphism. Next, regional metamorphism. It is when differential stress due to plate movement causes metamorphism. Next, shock metamorphism. It is when extreme compression of shock wave causes minerals to change its chemical structure that also causes metamorphism. Next is the results of metamorphism. The results of metamorphism include increases of state of stress, increasing of compaction of grain, increasing cementation and brittleness of rocks, and lastly, increasing of value of rock properties.
So guys, natapos na natin kung ano yung endogenic process. Ngayon naman, mag-reflect tayo sa mga natutunan natin. Balikan natin yung mga pinag-aralan natin. May mga natutunan pa kayo doon?
Yes, ikaw meron. Ikaw meron. Yes, meron.
Katulad ng sa earthquake. Kapag nag-earthquake, parang naapektuhan sa mga lugar. Katulad na nagkakaroon ng soil erosion, landslide, at iba pang pagka-tsunami.
Yan, and kaya hindi ko connect na din doon, yung sa soil erosion.
Erosion, kapag nagkaroon ng soil erosion, maapektuhan yung vegetation or farming.
So malaki din yung effect dun sa pangangailangan ng mga tao. Yes.
Pangangailangan ng mga tao.
Yes, sila yung vegetation nila. So, ako, na-realize ko dun sa volcanism na
So, ako na-realize ko dun sa volcanism na
ngayon ko lang ito nalaman. Although mayroon na akong some information nito sa dati kong pinag-aralan, pero ngayon mas lalo ko siyang naging detail na mayroon palang iba't klase ng volcano. So, meron yung padla at ang daming pati matangkad. Guys, alam niyo ba kung ayun yung malakas yung buto?
Yes!
Ay! Malakas na buto. Oh guys, nawalaan yung mga ano yun.
So, stratovolcano.
Yes, that's it. Stratovolcano. Kasi yun yung pinakamatangkad. So, pag pinakamatangkad, malakas yung pagbutok niya. Yan. Tama. Pero nice, nice. So, aside from that, meron pa ba kayong any condition? So, sa metamorphism,
iba-iba. So, meron din mga pre-crystallizations,
Yes.
regions. May mga nag-change na. Tapos yung mga minerals, pwede siyang mag-form ng new minerals. Kahit mag-break siya or mag-change, meron pa na mabubuo. So, yung negative effect is may masisira, pero yung positive effect, may mag-form ulit new minerals.
Nice. So, meron ba kayong experiences regarding dito sa topic natin? Like, for example, sa baha or whatsoever.
Yung earthquake meron.
Yeah, latest lang pala to. O ano, yung nag-earthquake din sa Manila, which is 695 or 5.
Yung nakakatawa sa
Share ko yung experience ko doon. Kakagising ko lang doon, then pagkatayo ko, akala ko nahihilo ko. Pero, gumagalaw talaga siya. Tapos pag nasa building ka pa, kahit tapos na yung pag-shake ng ground, gumagalaw pa rin yung building. So, ang pangit ng itsura ko doon sa position ko, kasi humawak talaga ako sa pader. Sabi ko, diba? Tapos yung kapatid ko, nakahiga siya, hindi niya alam na nag-earthquake. Then, na-realize na lang, sabi ko, uy, lumilin doon. Tapos pagka, tumayo siya, ang epic, kasi kinuhanan yung muna nilagay niya sa ulo niya, tapos tumakbo siya sa akin. So, yun. So, guys, ano experience mo dito?
Bakit na-experience mo?
Sige, bakit ako? Ikaw
Yeah, tapos nakakatawa sa akin. Yung sa akin kasi, nasa sinima kami na nag-CR ako. Ako po nakasakitol. Biglang lumintol. Alam mo yung tubig na wisik-wisik sa
Oh my God!
Nagkasama yun.
Paano yan?
Casey, go. Ay, wait, go.
Naman, hindi naman gano'n nakakatawa. Pero naramdaman ko yung earthquake. Gumuho yung buhay ko dapat. Wala. Ano tawag doon?
Naman ko yun nung tawag. Paglabas ko, akala ko meron lamang something na inuuga lang yung lamesa, gano'n. Pero yung pala, tilindol na pala. Tapos yun. Yun lang.
So, James, ikaw, asan ka nung lumilin doon?
Lagi.
Uy, next time! Hindi.
Nakagano din yun lagi.
Kaya,
Reyes yun. Hindi ko wala.
kasi
Wait lang, pero di ba, may narinig akong balita about doon? Ano daw, nag-bounce yung okay.
Hindi nakasakay ako kaya hindi kami.
okay.
Ikaw, ano, nasa pala?
Sa bahay. Yung pinakahiga ako nun, piling ko kinukuha na ako.
Dinner.
Ano kinukuha kanino?
Kinukuha na ako.
Ay, sinalit.
Ano nanginginig ba kinukuha ni Lord?
Kasi yung piling ko,
Bukas yung...
Umaakya.
So, meron pa ba kayo any addition sa
Yes. So, ngayon ko lang nalaman na yung mga mid-ocean ranges, yung mga rift valleys, yung mountains, yung mga volcanoes, ay may mga processes para sila kung bakit sila nabuo. Doon ko nalaman sa exogenic processes, sa tensional and compressional stress. So, yung tensional is yung divergent boundaries when two lithospheric plates ay naghiwalay. Yan, lahat naghiwalay.
Parang tayo.
Next is compressional stress. Two lithospheric plate ay nagsama. Para ikaw, wala ka naman, Joe, wala kang kasama. Wala ka naman, Joe, wala kang kasama. Reflection pala. So, ganun, kapag compressional, yung convergent boundary naman. So, nalaman ko doon na sa tensional, kapag nag-iiwalay, na-form yung mid-ocean ridge at saka rift valleys. And kapag naman compressional stress, so nagsasama sila, nagbububuan sila, so nag-form sila ng mountain.
Siyempre, mga.
Yes!